Thank you, everyone, for joining us at Griffith Observatory for a live broadcast of the northernmost moon. The moon is doing something it hasn't done for about 18 years. It is rising and setting as far north and as far south as it has ever seen. This happens each month over a period of 2 years in a cycle that lasts about 18.61 years. It's called Major Lunar Standstill, and we are now about halfway through the standstill season. I'm Dr. Ed Krupp, Director of Griffith Observatory, and this cheering and unusual astronomical event is part of a 2024-2025 campaign to follow the greatest monthly excursions of the moon. It is brought to you by Griffith Observatory, Griffith Observatory Foundation, and the City of Los Angeles Department of Recreation and Parks. Now, Griffith Observatory cameras are targeting this view of the San Gabriel Mountains on the northeast horizon from a point on the far west side of the observatory's front lawns. In a short time from now, the moon will rise on this line of light we've installed, and we'll catch it just about as far to the north as we ever see it. The waning gibbous moon, about 3 days past full, is 18 days old and about 86% full. It will appear over the mountain at about 7:43 p.m. Pacific Standard Time. It's evening here in Los Angeles. The sky is dark, and the moonlight will be bright. The Griffith Observatory live stream broadcast team is prepared to catch that moonlight. The broadcast team includes Patrick So, Observatory Theaters Manager, Matthew Burlando, Production Engineer, Vanessa Alarcon, Observatory Astronomical Observer, Digital Communications Coordinator Pixie Iwata, Production Assistant Ella Ritz, Carpenter Grant Armstrong, Stage Manager Michael Noble, and Griffith Observatory Deputy Director Mark Pine. Now, we first broadcast the southernmost moonrise and moonset last June and July. Here, in fact, is that southern moonrise from Griffith Observatory, and there's the line on the lower west terrace of the moonset, and in fact, there's the moon going down on that southern moonset line, and once more the moonrise on our installed moonrise line far to the south. But tonight, this is our first broadcast of the northernmost moonrise. The moon hasn't risen and set this far north since 2006. Its orbit is now tilted at the greatest angle outside the path of the sun. Those white disks in this diagram represent the moon on its path as it appears around the Earth, and the other circle is the sun's path as it appears from the Earth. On the ground, this means that over the next year, we'll see the most northern and southern moonrises and moonsets that the moon ever reaches. And those northern and southern extremes are outside the sun's limits, as you can see here. So here again is our major standstill moon watch view. The northernmost moon will appear on the line of lights installed on the front lawn. And here's an alternate view from Griffith Observatory's Astronomer's Monument. Well, the greatest excursions of moonset are marked on Griffith Observatory's lower west terrace, along with the solstice and equinox sunsets and moonsets when the monthly excursion is least, at minor standstill. So here, the gray lines for the moon's northern inner and outer limits flank the gold line that points northwest for the summer solstice sunset. The most northern and southern moonsets last happened in 2006, when the observatory was still under construction for renovation and expansion. The stone for the line had not been placed in the pavement yet, and this is in fact the major standstill northern moonset on January 28, 2006. Now, between now and around December 2025, the moon will each month rise and set as far north and as far south as it ever can. Again, in those positions far to the left and far to the right as you're looking toward a western horizon. And although we call this period the Major Lunar Standstill, the moon doesn't really stand still. Its monthly excursions just reach roughly the same maximum limits each month for about 2 years. The sun does something similar but it does it over the course of a year. In this illustration of the sunrise limits on the eastern horizon, the June sun is rising on the left as far north as we ever see it. And 6 months later, in December, it rises at its southernmost limit, then on the right. To the unaided eye, the position of sunrise and sunset at these times of year does not seem to change for about 3 days. The sunrise and the sunset seem to stand still, and the time when this happens is called a solstice, which means sun still. Oh, the Griffith Observatory cameras are still targeting the northeast horizon, where the northernmost moon will soon rise. Now, if we think of the sky as a hemispherical screen, like a planetarium dome, we can imagine how the sun, moon, planets, and stars all rise somewhere from the eastern half of the horizon on the near side in this view. And from there, they climb up the sky to their greatest height and then head back down to the western half of the horizon on the far side of the dome. The celestial objects all rise and set like this because the Earth is spinning on its axis, and that makes the sky seem to turn around the north celestial pole, a spot that's directly above the Earth's north pole. Now, if that were all that moves, the sky would be simple. But other objects in the sky, like the sun, moon, planets, also move around the sky on their own paths at different rates. The sun's path through the sky is called the ecliptic. It's just a reflection of the Earth's orbital motion around the sun. And the sun takes about 365 days, a year, to complete that circuit as we see it from the Earth, and the tilt of the sun's path shifts the sunrise and the sunset from north to south and back to north again in a year. Now, each month, the moon circles the Earth in 27 days. The tilt of the moon's orbit guarantees that the moonrise, too, will migrate from north to south and back to north again in that time. So the moon does in about a month what the sun does in a year. It moves from north to south and back again. But the moon does something else. The moon's monthly limits gradually change. Over 18.61 years, the moon's limits move from outside the sun's limits to inside the sun's limits and then back outside the sun's limits again. Well, the moonset lines on the lower west terrace of Griffith Observatory make this obvious. The northern inner and outer limits flank the summer solstice sunset line that points to the northwest here, and the southern inner and outer limits flank the winter solstice sunset line that points to the southwest. And when the moon rises and moon sets reach these limits, the limits really don't seem to change much from month to month. These periods then are called the standstills, one at the moon's inner limits and another at the moon's outer limits. The moon's limits still change through these periods, but the change from month to month is small, just as the daily change of the sun's position at the solstices is small. And that's why we call the moon's limits the lunar standstills. We are now in the season of major standstill, the time when the moon's monthly limits are far outside the sun's annual limits. The extreme moonrises and moonsets are farther north and farther south than the solstice sunrises and sunsets. But in another 9.3 years, the limits for the moonrises and moonsets will be inside the solstice points and will be at the minor standstill. The monthly limits will then gradually increase again, and in 2042, we'll have the next major standstill. So mark it on your calendar. Well, the moon behaves this way for two reasons. First, the moon's orbit is tilted a bit, about 5 degrees, compared to the Earth's orbit around the sun. Second, thanks to the gravitational pull of the sun, the moon's orbit swivels. That changes the angle of lunar excursion and the amount of the moon's reach. This Fisk planetarium animation shows how the rotation of the moon's orbit changes the angle at which we see it. These edge-on views of the Earth and the sun and the moon show how the moon's orbit flips from greater angle to a smaller angle and back again with respect to the sun. And although the varying limits of moonrise and moonset are noticeable over time, most people, including professional astronomers, have no experience with this aspect of the moon. You have to track the moon systematically, month after month, for several years to realize the moon is doing this. And you would have to track it for several 18.61-year cycles to see and understand the full pattern. And that's what we're doing at Griffith Observatory tonight. So, okay, we're still several steps ahead of the major standstill northern moon, which will show up soon. Well, despite the difficulty in mastering the lunar standstills, some investigations of archaeological monuments, particularly Stonehenge, have led some investigators to propose that lunar standstill alignments were designed into some ancient and prehistoric sites. In the 1960s, C.A. Newham and astronomer Gerald S. Hawkins independently identified lunar standstill alignments in the station stones rectangle at Stonehenge. The rectangle enclosed the main circle of stones and was constructed earlier, perhaps 4,500 years ago. The long sides of the rectangle coincide with the directions of major standstill southern moonrise and major standstill northern moonset. Here is the view to major standstill southern moonrise at Stonehenge. And here is the Stonehenge station's view to major standstill northern moonset. Hawkins also proposed sightlines between certain gaps in pairs of archways formed by the large sarsen stones, erected perhaps 500 years later. This pair of openings accommodates the major standstill northern moonset. Now, Stonehenge was not the first prehistoric monument assigned a major lunar standstill alignment. In 1908, British naval officer Boyle Somerville published a major standstill northern moonrise line for the Callanish stones in Scotland's Outer Hebrides. And in the 1980s, Gerald and Margaret Ponting instead favored an alignment to the low southern moon. Here that transiting moon hugs the horizon in June 1987. The late Aubrey Burrell was the leading expert on prehistoric stone rings, and he identified major standstill southern alignments in the recumbent stone rings in northeast Scotland. This is the view to the southwest from the center of the Castle Fraser stone circle there. The big recumbent stone operates like a stage across which the southern moon dances when it's making its setting. Jack Eddy, a solar astronomer, spotlighted a 2,000-year-old major standstill northern moonrise alignment shown on this plan of the prehistoric Hopewell Circle and Octagon mounds at Newark, Ohio. Here you're looking right along that line in the direction at which that northernmost moon would rise. And Steve Patricia here reconstructs Newark's major standstill northern moonrise back in the time when the Newark earthworks were constructed at the beginning. An ancestral Pueblo great house, about 1,000 years old at Chimney Rock National Monument near Pagosa Springs, Colorado, accompanies the restricted view of the major standstill northern moonrise framed by the distinctive rock pillars. Some believe the great house was built on this demanding mountain ridge to accommodate the northernmost moon in the Chimney Rock Gap. Griffith Observatory astronomical observer Vanessa Alarcon photographed this northernmost moon in October 2023, and Dr. Amanda Bosch of Lowell Observatory caught last December's moon, 2023, that full moon at Chimney Rock here. The Griffith Observatory remote live stream internet broadcast team captured and transmitted worldwide the major standstill northern moonrise at Chimney Rock this past September and October, and is scheduled to return next September. Well, despite deliberate inclusion of lunar alignments in ancient and prehistoric monuments has not been proved and remains questionable, Griffith Observatory, on the other hand, possesses intentional lunar alignments, and throughout the rest of 2024 and most of 2025, Griffith Observatory will broadcast selected moonrises and moonsets at the moon's maximum excursion. We are now about to broadcast live the Major Standstill Northern Moonrise from the far west side of the observatory's front lawns, along a moonrise line installed across the lawns, and headed northeast over the San Gabriels, a line that runs to the west of Mount Wilson. The moon may be standing still, but Griffith Observatory never stops moving.
Thank you, Dr. Krupp, and welcome to Griffith Observatory's lawn. By the way, happy birthday, Dr. Krupp. Dr. Krupp is the director of the observatory, and he could not be here in person at the observatory tonight, but we are celebrating his birthday by celebrating the rise of the Major Lunar Standstill moon. We are here live on the lawn of Griffith Observatory, and our cameras are pointed at the ridge line of the San Gabriel Mountains, which are to the northeast of Griffith Observatory, over the San Gabriel Valley, which overlooks the city of Los Angeles. And if you look over there right now, you can see that there is a slight glow. That glow is just to the left of some towers that represent the broadcast towers of TV and radio stations in the Los Angeles area. But those towers are also located on Mount Wilson, which is the home of the Mount Wilson Observatory, which is where, in 1923, Edwin Hubble made observations using the telescope at Mount Wilson, which was at the time the largest telescope in the world, made observations that proved that the Milky Way was not the entire universe. It was one galaxy in a universe filled with galaxies. He later discovered that the galaxies were all traveling away from each other at speed. The observatory has a program in the Samuel Oschin Planetarium called Centered in the Universe that talks about our place in the universe and how that figures into our stories about the sky. But our story about the sky tonight is the Major Lunar Standstill, which you've just heard about in terms of what it is and how it's happening. What you see here on the lawn is a sequence of 4 lighted poles that are guiding your view toward the northern horizon, in this case toward the San Gabriels, so that you can get a sense of where the moon will rise. It is the farthest northern rise of the moon along the San Gabriels during the course of the Major Lunar Standstill. And we wanted to set this up because on our lawn it is impractical to set up a line as we have inscribed in the West Terrace. The West Terrace has lines for the sunsets, for the eclipses, for the equinoxes and solstices, and it also has the major and minor lunar standstills. So tonight, what we created was this visual pathway on the lawn with these 4 lights that align to point you to the place on the horizon where the moon will rise. The moon is expected to rise at 7:43 Pacific Standard Time, which is in just a few moments. You can see the glow of the moon along the horizon, and so we're just going to wait for a few moments until the moon rises. Can you actually see the limb of it?
Yeah.
Okay.
There it is.
All right, then maybe I should say something. Should I say something? I'll say something. All right. Well, I think you can see that the limb of the moon has just crested above the ridge line of the San Gabriel Mountains, just ever so slightly to the west of Mount Wilson Observatory. The moon will continue rising over the course of the next probably 5 minutes or 10 minutes until it is fully visible. And you can see it along our line, which shows you that it is at its farthest northern point that it is going to rise. As you know, the Major Lunar Standstill lasts about 2 years. This is the first of 2 broadcasts that we're going to do for the moonrise of the north. The second one will be on Sunday, December 15th. We hope that you will join us then. We will have both a broadcast and a public event here on the observatory lawn so that people can observe the rise of the moon all together on a Sunday evening. So the moon is rising, and we will take a break from me talking so that you can enjoy planetarium music and watching the beautiful moon rise over the San Gabriel Mountains. We're live from Griffith Observatory for the Major Lunar Standstill Northern Moonrise. We are back here on the lawn of Griffith Observatory watching the northern moonrise for the Major Lunar Standstill here on November 18th, 2024. I want to thank you all for watching tonight and joining us for this astronomical phenomenon. Please join us again on Sunday, December 15th, when we will reprise this exact activity a little bit earlier in the day, and you will get to once again see the northern moonrise for the Major Lunar Standstill of 2023-24, or I'm sorry, 24-25. I want to thank everyone who made this broadcast possible, our amazing Griffith Observatory broadcast team, Griffith Observatory itself, the Griffith Observatory Foundation, which is our nonprofit support organization that is our partner in bringing you broadcasts and high-quality activities like this, the City of Los Angeles, and the Department of Recreation and Parks, of which Griffith Observatory is a part. Everything that we're bringing to you is free. The building and admission to the building is free, and that is a public service of the City of Los Angeles. So if you are a resident of the City of Los Angeles, thank you for your support. I want to thank all of our partners in putting these kinds of broadcasts together. I want to encourage you to join with us online this Thursday for All Space Considered, our monthly astronomy and space program that will take a look this Thursday at the Europa Clipper mission, which is on its way to the icy moon of Jupiter, where there is supposedly a massive ocean underneath the surface of the moon. That will be a fascinating look because that is part of the search for life. I want to thank you again for joining us for the northern moonrise of the Major Lunar Standstill 24-25. Join us again on December 15th. For all of us at Griffith Observatory, thank you and good night.